Okay, we're going to go ahead and learn how to find the derivative of a composite function. So a composite function just means that there's a function within a function, okay? So I'm going to use two different rules here for this lesson. We've got the chain rule, which is going to be on this page, and then we'll have the general power rule, which will be on the next page. Okay, they can both be used for finding the derivative of a composite function, but sometimes one's easier than the other, especially if it's written like in this form. It's easier to use this called the chain rule, whereas I think if it's in this form, it's easier to use what's on the next page, but I'll show you how to do these just using the chain rule for the first page. And then we'll try the next page with the general power rule. Okay, so first thing that you need to realize here, I suppose we should highlight it. When I'm using the chain rule, if f of u is a differentiable function, so it just means I can take the derivative, and u equals g of x is a differentiable function, so what's inside here I can also take the derivative of, then f of g of x is differentiable. And this is true here, so this is what I would highlight. Your dy dx is dy du times du dx. Or this is the more common way to see it over here. The derivative of f of g of x is you take the derivative of the outside portion and you leave the inside alone, and then you multiply by the derivative of the inside portion. It doesn't make a whole lot of sense until we actually do some problems, I know. Okay, so let's start here. We're trying to find dy dx. So we're going to use this here. If I'm trying to find dy dx, I want to find dy du, which means the derivative of y with respect to u. So I can do that here. What is dy du?
You got to plug in 3u squared.
3u squared minus 3. So just taking the derivative of this with respect to u. Okay. And then what else do I need here? Du dx, so let's find that. So it'd just be 8x, right? Okay, so any questions on what I did there? So that was just finding dy du and finding du dx. Does that make sense to everyone? Now what do we do with those values to find dy dx? We multiply them, right? And so we're going to multiply those together. So to get dy dx, I take my 3u squared minus 3, and I multiply that by the 8x. So questions so far? Okay, now what do you notice about this is it should be the y in terms of x, right? Do you see how there's this u in there? I don't like that u. What can I replace the u with? Nope. What's u equal to? 4x squared plus 1. So I'm going to replace this u with a 4x squared plus 1. I know it's ugly, but do you see what we're doing there? Okay. So this is going to turn into 3 times 4x squared plus 1 squared. And then minus 3, and then times an 8x. Now is it just in terms of x? Yeah, and then from here it's just some algebra. Well, I'm saying like it's not like a new thing. It's, you know, just multiplying things through. So let's do the 4x squared plus 1 squared. So what's 4x squared plus 1 squared? We have to multiply it by itself, right? So let's just write it down here. 4x squared times 4x squared is what? 16x to the 4th. And then I would have a plus 4x squared and another plus 4x squared, so that'll turn into a plus 8x squared, and then plus what in the back? 1. So that's this 3 times that, and then I still have that minus 3 times 8x. So questions? Then I would probably multiply that 3 through to get that out of the way. What's 3 times 16? 48. So I've got my 48x to the 4th plus 24x squared plus 3, and then I have a minus 3, so won't those cancel? And then I'm multiplying that by 8x, right? So I just switched this stuff in here, simplified it a little bit, and then what do I have to do? Multiply the 8x through. So if I multiply 8 times 48, does that give me like 384? So I've got 384x to the 5th plus 192x to the 3rd. So you can leave it like this, or if you want to factor out, a 192x cubed comes out of both of those, but this is fine the way it is. So the new part to this is this first line up here. Do we have any questions on the first line? The second line is just algebra, okay? And the second line is kind of where it looks or seems super complex, isn't it? But the first line, do we have any questions on that? You find your dy du, you find your du dx, and you multiply them together, and then just make sure everything is x's. So go back and find what your u is equal to plug in, okay? So any questions on that? We're going to try doing a similar thing with this one down here, except for they don't lay things out as nicely for you for this one. So we're trying to find the derivative given that my y is equal to x squared plus 2x plus 5 all cubed. So what I'm going to use for something like this, I'm going to use this piece over here. So my outside function and inside function, I have to figure out which one's which here. Okay, I have this, like what's in the parentheses is my inside function. Okay, so I'm going to call that my g of x. So my g of x function is that x squared plus 2x plus 5. So do you see how that's the inside piece to this composite function? And then f is the outside piece. What's happening to the x squared plus 2x plus 5? It's being cubed. So my f of x is just the x cubed. Okay, it's that thing cubed. So any questions on that part of it here? So now what I want to do is I want to take the derivative of my f and take the derivative of my g. So let's try to find f prime of x. What's f prime of x? 3x squared. And what is g prime of x? 2x plus 2. Is everyone okay with that? And now I'm just going to write this rule down, okay? So I'm not making anything up. I'm just writing this down here. So what I want is the derivative of f of g of x. And I know that's the derivative of the outside, the derivative of my f, and I leave g of x alone inside there. And then multiply by g prime of x. So now we just have to remember how to deal with composite functions, which we had back in chapter 1-ish, maybe 0. Okay, so I want the derivative of my f is what? 3x squared, right? But I'm going to put g of x in wherever I see the x's. So I'm doing, if you want to rewrite this, you could write this as f prime of, instead of g of x, what could I put in that spot? What's my, yep, my x is x squared plus 2x plus 5. So does everyone see where that g of x came from? Just here. So this is, instead of f prime of g of x, I'm putting f prime of what my actual g of x is. And then I'm going to multiply that by what's g prime of x? 2x plus 2. So I'm just plugging some stuff in now, okay? And my f prime was 3x squared. So instead of 3x squared, I do 3 of this squared. So that's just the composite function, just plugging that in for my x. And then I still have times the 2x plus 2. Questions there? Now I'm not going to multiply all this stuff out because it just gets super long and it's kind of nice being factored. What can I take out of this though? A 2. So if I take a 2 out, I'm left with 6 times x plus, what will this be? x plus 1 because I took a 2 out, and then I'm just going to leave this alone. So this would be my derivative. If you are thinking this is super, super complex and getting really confused, like I said, I think it's easier the second page. It's not terrible, but it's just a matter of remembering like what to put in where, you know. I think it's easier just, especially after you get some examples under your belt, but the second page I think is a little easier, just the way we go about doing it. Okay, but we're going to do the same idea for this one as we did for this one, except for I have that quotient piece in there. So let's first identify our g of x and our f of x. So I always start with the g of x because I think it's easier to identify what the inside piece is. And like I said before, the inside piece is like what's in your parentheses. So what is my inside piece here? Nope, even easier. Just x plus 1. Okay, so your g of x is just x plus 1. So then what would my f of x be? 1 over x cubed. Good. Your g of x is like what's in the parentheses or what like the middle part is of your function. So like this one, it was like this whole thing cubed, so this is your g of x, and then your f of x is the cubed portion of it. Okay. Same idea here. The g of x is this inside piece, so then your f of x has to be 1 over that cubed. Okay. So now let's go ahead and find our f prime and our g prime. So how can I rewrite f of x so it's easier to take the derivative? X to the negative third. That's a little easier to take the derivative of. So what's the derivative? Negative 3x to the negative fourth, which we can rewrite as negative 3 over x to the fourth, right? I'm just taking the derivative of this here. And then I'm going to take the derivative of g of x. What's the derivative of g of x? 1. So that one's nice and easy here. And then I'm just going to use this same rule from here. So I'm doing f prime of g of x. F prime of what's my g of x? X plus 1. Times g prime of x. What's g prime of x? 1. So the nice thing is I don't even have to worry about multiplying by this piece back here this time. And my f prime was negative 3 over x to the fourth. So what do I do with this x plus 1? Plug it in for x. So it turns into negative 3 over the x plus 1 to the fourth. Good. And we're actually not going to clean that up at all. And you're just multiplying by 1, so you don't even have to worry about that extra bit. The general power rule gets used all the time in calc. So this one's a huge one. Okay, if we have a function y equals f of x to the n, where f of x is a differentiable function of x and n is a real number, then this is true here. Okay, these two actually state the exact same thing. Do you see how it's the derivative of y with respect to x? This is saying take the derivative, right? What I do with my exponent is I pull it down front. So do you see how the n's down front? I leave the inside alone, and then what do I do with the exponent? Subtract 1. Doesn't that look very familiar? And then you have to multiply by the derivative of that inside function. Okay, that's called the chain rule. So you can think of it this way, you can think of it this way. I suppose this one is probably the more common way for it to look, but they're exactly the same, so it doesn't matter. These ones get used all the time. There's equations like this all the time. Like this type of a thing here. Yeah, you're going to see that a lot in calc.
That's how you
Okay.
measure pizza. That's how we're using it in real life situations.
Okay, so let's try to take the derivative of this. It's not as hard as it might seem, okay? So to take the derivative of this, you just look at, okay, this is the inside function here, right? The x squared plus 3x. So just leave that alone, okay? Leave it the way it is. So this 4 is the outside function. What do I do with the 4, with the power? Bring it out front. And you leave the inside alone, so we leave it as x squared plus 3x. And then what do I do with the exponent? So it's going to become 3. Okay, so you subtract 1 from your exponent. Then the biggest thing, the chain rule here, you have to multiply by the derivative of the inside. What's the derivative of the inside? 2x plus 3. Any questions on that? And yeah, you're essentially done there. So I'd probably reorder it here. Pull the 4 out front, put the 2x plus 3 next, and then put this cubed piece in the back. But yeah, this I wouldn't multiply out because it doesn't simplify to multiply it out. If you have like something plus something times something, like that can get simplified by multiplying it out because you can combine like terms and things like that. This here isn't going to simplify by multiplying it. Do you see how this is like a plus? So we have like separate pieces here. This is all one chunk put together, so you want to just leave it as that. Okay? All right, so we're done with that one. Let's try the next one here. What do I have to use for something like the second piece, or the second one? Yep, so this piece here I'm going to write as x squared plus 1 to the 1/2 power. Do you see how this was just all one piece here? This is actually two separate pieces. So what rule am I going to have to use from the other day? Product rule. So let's just rewrite my y. So my y is x squared times x squared plus 1 to the 1/2 power. And then we're going to use the product rule on it. But within the product rule, we're using the chain rule, okay? So product rule, what do I do? Okay, so I'm going to leave this one alone. So I'm going to leave x squared alone. And I'm going to take the derivative of this piece. And that's the new part here, okay? So let's do the derivative of this piece in a different color here. Okay, so just pretend this is the question. That's what we're putting in the parentheses. What do I do with this? Bring the 1/2 down front, and then do what with x squared plus 1? Leave it alone. And it's going to be raised to the -1/2. Does everyone see where that comes from? That's the, general power rule. It's also, the next part here we actually call the chain rule in AP Calc. So we pull the 1/2 down, leave the inside alone, it's raised to the -1/2. Then what do I have to do with this? You have to take the derivative of the inside, right? That's like the chain rule part of this. So multiplying by the derivative of the inside is what? 2x. So questions on that? So that's just leaving the first part alone and taking the derivative of the second, right? What do I still have to do? The opposite of that, right? So what's the derivative of the x squared? 2x, and then I'm going to leave this piece alone. Okay, so we're just going to try to clean this up now. Let's look at this first chunk up here. What can cancel out of this first chunk? Not the squared, but the 1/2 and the 2, right? Because a 1/2 times 2 would just be 1, so that piece goes away. And realize all these things are being multiplied, so my x squared, my x is going to give me what? X cubed. And then what do I do if something's to the -1/2 power? Yeah, you do. You know. Put it in the denominator, so it's going to become x squared plus 1 to the 1/2. And then this piece here, we can't really put anything together, so I'm just going to leave that as 2x and then x squared plus 1 to the 1/2. Now let's say I'm doing a multiple choice question and that does not match the multiple choice because all the multiple choice is just one fraction. How can I get this so it's just one fraction instead of 2? Common denominator. So what would my common denominator be? It's not going to take that long. X squared plus 1 to the half, right? So I would do that on top and bottom, right? What do you notice about that numerator? Anything? You have 2 of these, right? If you have this to the half and this to the half, what's it going to become? Just that to the 1 power. So in my numerator here, I've got the x cubed. And then back here, I've got 2x and then x squared plus 1 to the first. Does that look okay? And then my denominator is just, I suppose I can write this as square root. I'll write it like that in the next step. And then I just want to distribute that through and combine my numerators. So how many x cubes do I have in my numerator at the end? 3, right? And then 2x. And then the denominator I'm just going to write as the square root. Again, a lot of this, like the hard part, is the algebra, you know. Do we have questions on the chain rule or general power rule portion of this? If I call it the chain rule, it's just because that's what it's called in AP Calc. Okay, so this is actually called the chain rule in AP Calc, whereas this book calls the front page the chain rule. So any questions on that? Okay, we're going to try the bottom one here. Okay, so the bottom one, find the derivative. We're going to use what rule within general power rule? Quotient rule. Okay, so if you look at this, the inside function is what's in the parentheses, right? So first thing I want to deal with is this squared. How do I deal with the squared? Okay, so I'm going to bring it down, so let's just call this dy dx. So we'll pull the 2 down front, and then what do I do with the parentheses stuff? Leave it. So this will just be x plus 1 over x minus 5. And then it's going to be raised to the what power? The 1, so I'm not even going to write it down. And then what do I have to still do? Derivative of the inside. So if I take the derivative of the inside, just do low d high minus high d low over the bottom squared, and away you go. Okay, so low d high is 1 minus high d low is 1 over the bottom squared. And away we go.
Where are we going?
I'm not sure where we're going yet, but I think so.
I'm okay with that.
Okay, so now I've got in the numerator this 2. You can think of this as 2 over 1 if that helps you. Put your numerators and denominators together here. So I've got 2 times x plus 1. And then what is this stuff here going to turn into? What'd you say? No, I heard it. Negative 6. Yeah, because the x and the negative x will cancel. And then the denominator I have, x minus 5 to the 3rd power. And then I'd probably multiply that 2 and negative 6 out there. Whoops. Why did what disappear? Oh, because I hit back. So take a look, see what if you mess that up. Do you guys see where this negative 6 came from, though? Distributing the negative. You get negative x minus 1. Okay. So this I would just write as negative 12 times x plus 1 over x minus 5 all cubed. And then that's done. You can't simplify it from there. Did you see what went wrong, or? I just left it because it's 2 times this times negative 6, so I just multiplied the negative, or the 2 and negative 6 together.
It's
Oh, could you multiply the negative 12 through? Sure, you could.
You're right,
This here, write that part out. Yep, so if I have this x minus 5 and then minus the x plus 1, you just distribute the negatives. So you have x minus 5 minus x minus 1, and then the x's cancel. So then you have negative 5 minus 1 gives you that negative 6. That was just from up here. We had the 2 times x plus 1 times this. All the numerators are getting multiplied. Okay, does that make sense? And then the denominators, you see how it got cubed? Okay. Any other questions? Okay. So homework is there. You guys can go ahead and work here. I'll